four distinguished scholars with us. Dr. Jonathan Mark Canoyer, Dr. Marco Modelo, and Dr. Abdul Samad. And the chair and discussant for this panel is Dr. Nilofer Sheikh. So over to the participants. Thank you.
Good afternoon, everybody. I should say that I feel very honored and also very humbled to be here to speak in front of such a collection of personalities and colleagues. And also I feel very honored that the chair of the session in which I'm speaking is Professor Nilofer Sheikh, who is the first person I've been working with when I came first to work in Pakistan a long time ago. My presentation is not about the Indus civilization yet, but is trying to understand, or at least making suggestion, a hypothesis of the possibilities of the beginning of this civilization and how it came to be. What I'm talking about is somehow the brainchild of two projects that our research group has been dealing with for the last few years. One is Simulpast, which is a modeling and simulation project that we had running for 6 years now, and it's closing down. And one of the major point of focus was effectively South Asia, but we have many other also case studies from around the world. And the other project was the NOGAP, which is a project that has been running for the last 6 years also in North Gujarat as a collaboration between our university in Barcelona and the university, the Maharaja Shaji Rao University in Baroda. And working in North Gujarat, we came very well aware, especially because of our site are quite early, of the presence of wild and domesticates in our site, and also of the fact that we were the first of having strong data collected in a very, how can I say, systematic way. And this data start to give us some thinking about how agriculture came to be in this area of the world. Our main site and some of the dates, but in parallel to this, obviously we have data from other sites that has been excavated earlier, and currently the earliest evidence for cultivated plant in South Asia and at the rim of the Indus Valley is Mehrgar period 1, and where we find different type of wheat and barley, and also a combination of other plants that were not cultivated but were obviously gathered during the occupation of the site. Now, how agriculture came to be? Well, fundamentally, in general, there are three possibilities. Is a local development or arrives through two main mechanisms of spread, demic and cultural diffusion. Demic diffusion is we have dispersal of farming, little group of people that start moving farther and farther, new people keep moving, and they colonize new territories, territories that probably were occupied before by hunter-gatherer. These are totally or partially displaced, and the new population takes hold. The other way is cultural diffusion, in which the idea of cultivating, the idea of a new technology is taken in by the hunter-gatherer or by nomadic people, and once it's acquired, these people become themselves agriculturalists. So, what is the context for South Asia? What we know till now? I mean, the first thing I should say is that in terms of archaeobotany, in terms of plant evidence, we don't have many evidence of early domesticate in South Asia. And as I was saying, Mehrgar is fundamentally the only site for which we have very early evidence. But in the last 15 years, we start to have many other parallel evidence indicating, suggesting possibilities on how the agriculture came into South Asia. One of the studies that opened up this perspective was a study by Cavalli Sforza in 1994 before, in which it was pretty clear that there was a first principal component of Asian gene frequencies that reaches its maximum in the Near East. What that means, that fundamentally the population from South Asia have a strong and important genetic component that comes from the Near East. Also, more recent studies, like the one from Quintana Murci, they show that the Y chromosome, the male chromosome, lineage AG9, displays a cline of decreasing frequency from the Near East to India. So that means that fundamentally, again, we have a population that somehow the suggestion originated in the Near East and somehow dispersed eastward. Furthermore, we also have other very recent information related to genetic similarity between traditional and recent agriculturalists in South India. And again, also this one suggests a spread of the agriculture, at least in the Indian subcontinent, in endemic form, so through people. So all this information is obviously from modern population. We're not talking about, ancient bodies. These are genetic studies on modern population, which suggest a mixture of demic and cultural diffusion for the agriculture into South Asia. We don't know exactly which one of the two was the most important, and we still don't know very much about the mechanism, at least from this perspective. There's been also very recent studies on ancient DNA. On ancient DNA from population in the Zagros mountain, that shows affinities with modern Iranian, Afghan people and Pakistani people. And again, it suggests somehow that the Zagros, it's an important point of origin for this population. What is interesting in here is that the studies on the modern population show a general tendency of origin towards the West. But ancient DNA is showing that actually the focus of origin seems to be, at least genetic, seems to be a bit farther east in respect of what we were thinking, and is the Zagros area. So where we stand after this? I mean, our work was, well, we have important information, important data that has been acquired over the last 40 years, or excavation carried out by Pakistani archaeological mission, Indian archaeological mission, foreign archaeological mission that have been working and collaborating in this subcontinent. And so the idea was, why not to take advantage of that data that is available? And so we did some mathematical and geostatistical modeling to assess the spread of the Neolithic across South Asia, starting from the hypothesis that we saw from the ancient and modern population DNA. We wanted to explore the patterns, both at global level, so from Europe to here, and also at regional level. And then we wanted to try to understand if there was, which one of the two possibilities was the most important, if any. So we started in gathering a database, and through all the published information, we gathered all the radiocarbon dating. And of all the published radiocarbon dating, we selected only, and I underline a lot, only 74 archaeological sites, spanning from Iran, Iraq, Turkmenistan, Afghanistan, Pakistan, and India. So, as I say, straight away, maybe not all of you can read down there, but it says limitation. I should have put it in, in flashing, because the number is small. When we work statistically, we really need to have bigger numbers. But we thought that in any case, it was a good way at least to put, a first perspective on this kind of studies. And then we also collect 16 pre-pottery Neolithic B and C from the Near East that are also the site that has been used to understand the spread of the Neolithic from the Near East to Europe. The first part, we did some mathematical modeling to try to understand the linear fit of our samples And what we see is that there is a very good linear fit. All our samples are the crosses. The triangle are the PP and B in the Near East. So all our samples are quite well fitting along this linear fit. And we have only 3 outliers. One of them is Mergar, effectively, because is the dot that you see just on top of 3,000 in there. And that's why. That's because it's a very old date in Mergar. So, and the other 2 are 2 sites from India, for which probably there are also a little bit of problem with dates, so I'm not very worried about those outliers. But in fact, however, even if Mergar is an outlier, at least statistically, we have to consider that all of the other sites are agreeing between themselves very nicely, and they have a 95% confidence interval, those 2 lines. So I think it's worth to explore this fact. Keep it in mind, Mergar is there, is sitting, on the shelf, but we need to explore this situation. And a first possibility of exploring our data was to say, okay, if the Neolithic, somehow we can hypothesize that there is a common focus in which it started, how can it compare with the other expansion that we know and has been studied quite a lot with an enormous number of sites, things like that. So there are 3 possibilities of comparison between Europe and South Asia. We can have that the Neolithic started at the same time but has different origin geographically, or started at different time and different origin, the one down there, different time and same origin, and same time, same origin. So these are the 4 possible scenarios we can think of, as a comparison between Europe and South Asia. And here is our work. And what we see, that you see straight away the data set from Europe, 900 dates, and our data set, 74. We do our best. And what is pretty clear is that the European and Asian wave of advance propagated from different spatial origin, but not necessarily at different times. And the other thing is that the fitting line for Asia is steeper than Europe. So it suggests that the spread of the Neolithic into South Asia was slower than what we saw in Europe. The next step was to say, okay, this is a little bit of, of graphs and a little bit of points, but how can we also visualize this movement? So we did a second round of analysis doing geostatistics. And geostatistics is an analysis that is quite interesting because not only gives us some very good information about the level of confidence we can have with our data, but also is able to visualize that information in a very useful way. And the first thing that we see is that there is a certain spread, in terms of date in the Near East. It's quite wide. And then there is, where there is the oval in white, there's kind of a stopping in there. All the data coagulate in there. What that means, fundamentally, that a kind of a moment of stopping of this change, this, the spread of this change. And then once it's over, again, it starts reasonably fast and regularly. That area, circle, is the Zagros Mountains. I think I'm not going to see any of you with these things in front of me. And another way to look at the data is to try to understand the speed of the spread. And again, the previous one, this one is simply plotting the dates that we have in each site. But we can also try to understand the speed of the wave movement. And again, what we see is that there is a stall moment, a moment of, not spread. But again, it's at the Zagros Mountain. What we have also, the green and blue in the center, are simply noise, uncertain speed. That's because we don't have a lot of data points. So obviously, over such big geographical area, we expect something like this. So the Zagros It's quite interesting because it's a very high mountain range. It reaches 3,600 meters. So obviously it's a physical barrier. It's definitely not an ecological barrier. On the west and on the east of the Zagros, we are exactly in the same type of ecological setting. So it was not that, people arrive at the Zagros and, wow, it's a completely different thing. We have to do something differently. We don't have the package to go over. No, it's fundamentally probably the fact that it's a big chain of mountains and it's difficult to cross. And so people settle on the western side of this mountain, and it took a long time to go over them and to create a new outpost on the other side. So, conclusion from this very little contribution that we try to give, and I know that for some of you this might even be quite controversial, so the first thing is that the inferred spatial origin of South Asian Neolithic is different in respect to the one of the European Neolithic. That's the first thing we can say, and this suggests independent origins for the agriculture. The Levant for Europe, and the Zagros region, with all probability, for South Asia. The wave of advance propagated after Zagros quite regularly, all the way through Middle East, Afghanistan, Pakistan, and then went into Indian subcontinent. And as I was saying before, the Zagros mountain had a role of a very strong physical barrier for 1,000 years. So that's a long time. And once they are beyond, the way of spread is very similar to what we see in Europe. And my interpretation, without attaching too much to it, is that the fact that, again, they were still in the same kind of environmental situation, so it was quite easy to move forward. And finally, the type of speed that we have calculated suggests that it's mainly endemic diffusion. So it's mainly small group of people that were moving eastward with this technology. And this is what we know now. In 5 years' time, we might have 200 more sites, very well dated, and this conclusion can be very different. And it actually would be very interesting to see, if we arrive to a different conclusion. But I thought it was important to make some assumption. It was important to try to explore the pre-Harappan, what happened before the Indus civilization, what we have, were the first step of this great civilization. And I think exploring the Neolithic, and possibly, hopefully in the future, we will have more data from the Neolithic from Pakistan, it was a good way to start thinking about it. I would like to really thank all the organizers of this Mohenjo-Daro conference, the National Fund for Mohenjo-Daro, the government of Sindh and Pakistan. Really, I'm very honored to be here. And all the people that have worked with me during these two projects, and then various colleagues, most of it Cameron, that gave feedback on this talk. Thank you very much.